All right, today we're going to be talking about fire season in California. So, what's the difference between summer and autumn? And then going to bring up this new term called the fire window, which is different depending on which fuels you're talking about and how long it's been since you recently had a fire. This is all stuff that I was learning in Fire in California's Ecosystems. Finally made it to the end of the fire weather principles chapter, and then the next chapter coming up looks pretty interesting as well. So just getting into fire season in California, it's really split up into summer and autumn. So during summer, not a big surprise that you're going to be able to have some wildfires during summer because California has a Mediterranean climate, which means we pick up a lot of our rainfall in winter, and then summers are dry. So at the hottest time of the year, it's also typically the driest time of the year, very low relative humidity. So then our fuels start to dry out, and then the longer it's been since you've had rain, just the more and more those fuels dry out. So in California during summer, one of the key factors that's going to determine your fire danger, especially along the coast, is what the marine layer is doing. This will be just a layer of cool, moist air that when the jet stream moves a little farther south, the marine layer stretches out, and then it's able to push farther inland, so that brings some of the clouds down your coastal valleys, brings some moisture back into your fuels, maybe even a little fog along the coast. And then when you have a big high pressure system overhead, you have a lot of descending air, and that's almost just going to pinch the marine layer back to the coast. A lot of times it'll make the marine layer shallower, so you can get denser fog right by the ground, but it usually burns off earlier in the day, and then you have some sunshine in the afternoon. And when the marine layer is shallow, the clouds usually don't push very far inland, so then your inland areas are going to be sunny all day, and then with the big high overhead, they're also going to be warmer. So basic takeaway there is during summer, especially along the coast, one of the big question mark is what is the marine layer doing? And on days where there's a high moving in and it's making the marine layer more shallow, your clouds are going to pull back to the coast and you'll have higher fire danger in your inland areas. Now, when it comes to the kind of fire behavior that you see during summer, it usually has to do with what your fuels are doing. How dry are they? How continuous are they? Because your winds are going to be pretty repetitive throughout the summer. It ties back into what I was talking about the other day in my wind video, where during the afternoons, especially in valleys, your mountainsides are going to heat up faster than the valley. So you're going to get a lot of rising air there, and then that air has to be replaced by something. So you get air rushing up the valley, up your mountain slopes. So this will lead to usually the most extreme fire danger that we have during summer. It's in the peak of the afternoon when it's very hot out, it's very dry out, and then you also have those winds pushing uphill. The reason that's important is because fire already likes to go uphill. The flames tilt over, heat up some of the fuels ahead of them before the fire even gets there. So it's able to move faster uphill, and then you throw in those afternoon winds flowing uphill as well. And that's usually where most of your acreage burned is going to be during the afternoon hours. And then overnight, the opposite happens, where now your mountain sides cool down faster, and then along the ground, you have this layer of cold air, but that cold air is more dense, so it almost just sinks and settles down into the valley. So that's going to lead to some downslope winds as well. Usually those aren't as strong as the upslope winds that you had during the afternoon, and backing fires are usually much less intense, and that would be at nighttime, so it's going to be cooler, there's going to be more moisture, and that's also a big part of the diurnal pattern, is it's hotter in the afternoon, so your air can hold more moisture, which means the air gets drier, lower relative humidity, and then at nighttime, your temperatures go down, it can't hold as much moisture, your relative humidity goes up, and then some of that moisture finds its way into your fuels. So summer, very diurnal pattern. The big question mark in summer is sometimes we can get those thunderstorms as well, where you get maybe a hurricane off of Mexico that funnels in some moisture or some monsoonal activity, and then thunderstorms there's three things you have to think about there. Will lightning lead to fire ignitions? Will the gusty indraft and downdrafts from the thunderstorm lead to rapid fire spread or erratic fire? You could also just say erratic fire spread. It's just in all sorts of different directions. And then will you pick up enough rain from the thunderstorm that some of the moisture actually finds its way into your fuels and helps you out with fire danger? Usually not, just because the thunderstorms move so quickly through an area. So that's your summer environment. And then what happens is you end up getting into autumn. And this, I would say, overall, fire danger is decreased in autumn because you have those cool patterns that can start happening. During summer, it's pretty much nonstop high pressure system over the Pacific. That leads to some warm conditions over California. It's very dry. It's northwesterly winds almost every single day. It's, as a weatherman, the summer pattern gets pretty repetitive. I could almost have the same forecast for probably 45 out of 60 days. But then during fall, things start to change around a lot more. You can still get some of those summer patterns where it's very warm out, above average temperatures. Right now, we're seeing triple digits in the Salinas Valley. It's beginning of October. But then next week, there's a chance for some rainfall. So that's what happens in autumn is you have that swing. It's kind of the middle ground between summer and then winter. And you start to just transition back and forth between the two. So on average, that's going to lead to less fire danger because you have more of those cold periods and maybe even picking up a little bit of rainfall. But during autumn is also when we have what you could say would be our most extreme fire weather conditions of the year. It's just over a shorter period of time. So that's why it's on average your fire danger is less, but over short periods of time, your fire danger can be the most extreme it's been the entire year. And you probably know where I'm going with this. I'm talking about the big offshore wind events, the downslope windstorms, Fern winds, Santa Anas, Sundowners, Diablo winds, whatever you want to call them. That's all kind of the exact same thing. A lot of that setup is where you have a high pressure system kind of on the eastern side of the mountains and then a low pressure system off the California coast. So you have this air that wants to go up and over the mountains. And then as it's coming down the backside, as the air goes down, it's going to warm up. And as I mentioned earlier, as it warms up, it gets drier. And then it's also going to start going pretty fast. You have some gusty winds in this case, especially with like the Santa Anas you see in Southern California. Very warm, very dry air. And then the winds will be funneled through canyons. So you'll have 40 to even 65 mile per hour winds. In some cases, maybe even more than that. And then if you haven't had a big rainstorm yet, those fuels have been drying out the entire summer. So fuel-wise, it might be the highest fire danger that you've had. And then on top of that, you're getting these warm, dry, gusty winds kind of mixed with those very dry fuels. So that can lead to very rapid fire spread, very extreme fire behavior. But then it's usually, once those offshore winds die down, the fire activity goes way down. So it'll be a quick burst of fire activity versus during summer in the olden days, you might have a fire burn for 3 months straight. Whereas during autumn, it's going to be more of that kind of peak pattern. And then when our fire danger starts to calm down more is once that first good rainstorm of the season happens. And that usually brings a lot more moisture back into your fuels, and then hopefully that pattern just continues throughout the winter and you end up picking up more rainfall. So that explains what you could describe as the fire window. Obviously, there's maybe a few fires that start popping up in spring, maybe a few fires that still happen in winter. But what I mean by the fire window is the amount of time that you can propagate fire across the landscape. Now, interestingly, this depends on the fuel that you're talking about. If you're talking about grasses, you can have a fire even if you're above 50% relative humidity. Just because grasses, it's just like, how do I explain it? If you're starting a campfire, it's easier to start the fire with small needles, maybe small leaves. I believe it has to do with the surface area to volume ratio, something sciencey like that. But just taking the science out of it, you just know it's much easier to burn a grass than to maybe take a lighter to a log and try to light that on fire. It's probably not going to happen. So in grasses, your fire window is longer because you can still sustain fire on days where maybe there's some decent moisture in the air. Now in your woody areas and your forest, then it actually does have to be pretty dry to sustain fire. But then to even get more nuanced, in your forests, it really depends on how long it's been since you had a fire. Because when a fire comes through, burns out the vegetation, kind of cleans things up, clears out a lot of the dead fuels. So in an area that hasn't burned in a long time, there's going to be fuel accumulation, which means it's going to be much more continuous, which is much easier for fire spread because it goes from plant to plant to plant. Whereas if you have less continuous fuels, the fire might burn this plant, but then it's pretty hard to jump over to the other one. So you have fuel accumulation. You also maybe have some dead fuels accumulating that would be extremely dry and easy to burn. And then if you're talking about live fuels, you're also going to have a larger number of plants sharing the same amount of water. So if you just do the math on that, each plant has less water. So each plant is going to be drier. It's easier for those plants to burn, so that would make your fire window longer. Basic summary there is, if it hasn't burned in a while, your fire window is going to be longer because there's more days per year where you can sustain fire. And just something interesting that popped up into my head, thinking about that factor about how the longer your fuels accumulate, the more water they have to share. That's something that we saw play out in the Sierra. We didn't allow a lot of fires to happen up there, so we ended up with way more trees per acre than the environment should naturally sustain. So all those trees were sharing the same amount of water that a lot smaller number of trees should be sharing. So each tree had less water, so then each tree was, just say, weakened, and it made them much more susceptible to pests and insects and disease. And then what ended up happening is the environment always tries to find a way to balance itself out. So we had millions of trees die up in the Sierra, and then that just sets the stage for extreme wildfire behavior where a fire, now when it goes into that area, it has lots of fuel to burn. So it's almost like the ecosystem. If you don't allow it to burn, it will find a way to burn. And then just from the human perspective, we can either decide to have more numerous, smaller, low-intensity fires, or we can kick the can down the road, allow fuels to accumulate, and just wait for kind of the bomb to go off, or for that explosive growth that ends up happening because you didn't allow fire to naturally manage the landscape. So that's just kind of what I've been learning so far throughout this Fire in California's Ecosystems book. I'm going to continue to read this, so if you want to learn more about wildfire, stay tuned, and thanks for watching.